Good morning, Amy. How are you doing?
Oh, hi, sir. I'm good, thank you. How are you?
Very good, very good. So, how's your preparation for exams going on?
Yeah, all right. I'm just going through past papers and doing the method that you showed me last week, where
Mhm.
I look through exam questions and then from that review of the exam paper, quick, like rough review, I can figure out which contents and topics I need to revisit instead of starting with that and then going the other way. And so, yeah, I'm definitely picking up on the topics that I've missed up on, and I'm actually surprising myself with some topics that I actually remember, which is like from way back. So, at least it's like, yeah, it's good progressing.
Yeah, these days we normally have semesters in which very limited courses to be reviewed. But in
Right.
your case, you have to review the whole thing. It's like a final exam, right?
Yeah,
The
whole year's
concept
worth
of
of
exam,
content.
which is now going away from many parts of the world, is actually
Right.
very important because everything comes together, and normally we intend to forget what we learned about 6 months back. Correct?
Right. Yeah.
So that is why it is natural to recall it, and difficulty in recalling it is always there.
Yeah.
But I hope we should get into this practice of understanding and recalling better. So that's a part of learning, actually. It's a very important part of learning. And the examination systems which you still have in UK is pretty good, and it should be actually encouraged. So I'm very
Hmm.
happy about that. But in North America, I've seen that, we have only semesters, and these days, because of the COVID, we have quad. That means just 2 months. So
Oh.
hardly students learn anything in 2 months. They will have a final test and the course is over. Well, that means we are not really testing the students on their retaining powers of
Right. Yeah.
topics, or even a deeper understanding or recalling and applying the concepts learned. So the
Yeah.
major part of education is lost when we get into these semesters and quads.
Yeah. That's true.
I'm glad you still follow the annual system, and apart from the regular quiz assignments and tests, you do have a final exam. That's very
Yeah.
good.
Mhm.
Okay, so now which chapter are you reviewing, and what kind of difficulties are you having, so that we could today learn how to solve those things and move forward?
All right. So I've been touching up a lot on pure, and that's all right. It's going well. It's when I hit the mechanics part. I think we even discussed this before when we were doing like pulleys and things like that.
Yeah, yeah.
I found it quite tricky because my brain's not like wired to be very physics based. So, and I was never like that physicsy even at GCSE level. So that's why I'm finding this a little bit tricky. But yeah, so do you think we can review a couple of questions for mechanics and then?
Sure, sure. It's very interesting. I mean, mechanics is not the part of mathematics in most of the part of the world.
Yeah.
I'd like you to introduce yourself once again for the benefit of our students. Tell them what you are doing, what is the math curriculum which you are following, and how this mechanics and statistics is also part of curriculum in your
Okay.
school. Can you
All
tell
right.
us about
So
that?
yeah, so I'm a year 12 student based in UK, and with the maths curriculum, basically it's kind of weighted in a weird way. But for year 12, we've got this big book here. It's quite thick. This is all pure. This is just year 12 content, and then we've got another one of these for year 13. And then based on mechanics and statistics, it's kind of split in half, which is this book. It's
I
a bit
see.
smaller, and it's definitely equally split between stats and mechanics. And we definitely, the teachers focus more on the pure side since it's obviously containing more of the percentage of the marks. But still, this stats and mechanics is like new for half our year group because we don't do it at GCSE level.
Mhm.
Some schools do, but because of now COVID and everything, no one really got a full take on statistics or mechanics. So yeah, I think I feel like I'm spending a lot of time on this book, even though it's quite like a smaller chunk. But I feel like I do want to understand the concepts instead of just like passing it by. So yeah, that's the course pretty much.
Well, it is important to understand, Amy, for a student like you who wants to achieve more than 90% marks. Mechanics may have a smaller say in the number of questions. However, the weightage will be more than 20% marks.
Yeah, for
So if
sure.
you lose that, then you're fallen below 80, right?
Right, right.
So looking into that and understanding the weight, it is heavily weighted. And the
Yeah,
questions in mechanics are not so simple as in the general mathematics which you study.
But apparently in like for UK in half of our, apparently this is the thing according to my teachers, stats and mechanics is apparently like easy. So the grade boundaries are so tight. It's like between 1 and 2 marks you can go different levels, like whole grades, whereas pure, the spacing between each margin is like about 5 or 6 marks, which is enough spacing. This one, it's like crazy tight. So you need to be really good in these two.
Yeah, so that's a niche area which you should really understand.
Yeah, yeah.
And moving forward in universities, this subject will really help you in vectors, calculus, and physics, of course. So
Right.
it's a strong foundation which you're building now, and it is going to help you in times to come. So it's a
Yeah.
good time to review. Now, in mechanics, tell me, what kind of questions are you facing difficulty with so that we could come up with some solution and understand how do we solve such questions?
Yeah. So in terms of what we did, like the questions where we did it like over a pulley and how we make assumptions so we know the acceleration is constant, tension is fine, those are all right. And even like things on tables and then falling off. But then I came across a question where it had one box like a particle here and then it had another one on top.
Mhm.
And there was some vertical force acting on it. But I thought the vertical force was acting below it, or
Mhm.
I don't know whether it's on top or below. So that's where I
I
found the
see.
difficulty.
I see. So as far as I understand, can you read one of the questions so that let me
Yeah.
understand clearly what you're talking about?
Okay. So this is question 6 from a book. Okay. So two particles, A and B, of masses 10 kg and 5 kg respectively, are connected by a light inextensible string. Particle B hangs directly below particle A.
Okay,
Um, a force of 180 newtons is applied vertically upwards, causing the particles to accelerate.
right. Okay.
Part A.
Mhm.
Find the magnitude of the acceleration. And part B, find the tension in the string.
I see. So what you have basically is two particles, one above the other. They are connected by a light inextensible string and they are being pulled upwards. Since they are being pulled upwards, there will be an acceleration because that is an external force. And whenever external force is applied to a system, right,
Yeah.
Newton's second law, it will be in motion and will give a constant acceleration in this case, which will be mass into acceleration. Correct?
Okay.
So this additional force, if it is more than the force of gravity, which is actually pulling the masses down, in that case you can have acceleration upwards. So definitely this force which is applied upwards is more than the combined gravitational force of both the masses.
Yeah.
So we also learned a concept that in such cases, when you have a string in between, those two masses could be considered as one chunk of mass also. So you could
Oh,
also simply take m1 plus m2 times a, which is the acceleration, and the upward force will be force applied F minus m1 plus m2 times gravitational force.
oh,
And there you can very easily find acceleration as force minus the downward force, which is m1a, m1g, and m2g, right? Those two
G.
parts. Good.
Hmm.
So that is the net force. And this net force is equals to the net mass into acceleration, right? So
Oh,
mass is the combined mass m1 plus m2, and a is the constant acceleration which is given to you. And now to find the acceleration, just divide by the sum of masses, and you get your result. Do you see how
oh,
kind of visualize it? But I think at this stage, it is very important since you are doing the review for me to take you over what we learn quickly within 5 minutes.
yeah.
In that
Okay.
way, you will also understand how do we review for final exam, right? We learned
Yeah.
this concept over a period of, let's say, 3 weeks, correct? But
Right.
now we hardly have 3 days to review. How do we understand or recall what we had learned over a period of 3 weeks in, let's say, 3 hours?
Yeah.
That is
Yeah.
what the timings should be now, right?
Mhm.
So we'll quickly go through that. Then again, come back to your question, solve it. And our solution will be a general solution. Because in the book, what you really find, the book gives you some practice problems, right? So in the
Yeah.
book, what we have is there are two masses. Sometimes they will give you one mass, they will not give you the other mass. Sometimes they'll give you the acceleration, sometimes they'll give you the force. One of the
Right.
variables, one of the thing or parameters is unknown, which you have to find from the given situation, right?
Yeah.
So what we will do here is, as you understand, we learn these skills to fish. I don't really provide you fish on the plate, correct? I
Yeah.
provide you the techniques of
To
getting
get
it
the
on the
fish.
plate, right? That's what it is, right? So let's go through what we had learned. I'll share with you some old material which we had talked about. So now let me share the screen with you.
The main thing that I was kind of getting a bit confused about was when certain questions, how do you know when to treat the whole thing like a whole system or when to individually look at particular parts of the system?
Right.
Because
So
sometimes questions aren't clear, so I was a bit confused about
I
that.
think you have a point there. So let me just share the screen, and as we go through the examples which we had done, right, that'll be a good quick review for you. You will understand and get the solutions or answers to most of your questions, right? If you don't get some answers, you can always ask me at the end of the class, and I'll explain you all the concepts all over again. There's no problem in that, correct? So to begin with, we actually, you remember, can you see my screen, Amy?
Yes, I can.
Okay. So to begin with, we started with, when we're talking about the two masses, we said, well, let's keep the masses on the table. That becomes the simplest of all the examples. And we are assuming no friction between the masses and the table, correct? So
Right.
in this
Yeah.
particular example, there is no friction. A force is being applied. And whenever the external force will be applied, we'll base it on the Newton's second law of motion. We'll say the whole system will be into acceleration. So MA is equals to the net force applied. Net force really means the force applied and force which is resisting it, correct? That is the
Yeah.
basic concept. So here, can you read this question, please?
Yeah. So two boxes with mass of 12 kg and 10 kg are resting on a table. The horizontal force of 40 newtons is applied by a person to the 10 kg box as shown in the figure.
Correct.
A, find acceleration of each box, and part B, find the tension in the cord.
Right. So in most of the questions, there are only two things which we need to find. One, acceleration. Second, tension in the cord of the string.
Yeah.
All the questions, 90%. Have
That's
the
true.
same thing. And therefore, what we should do is we should generalize the solution, correct? It
Right.
doesn't matter whether this is 12 kg or 10 kg or 40 newtons of force. It doesn't matter. We have to understand the concept. Is that
Yeah.
clear? Right. Okay.
Yeah.
Now, these two masses, I can actually combine these two masses and make them 22 kg and solve the problem very easily. You understand? So
Mm.
coming back to your question, when to combine, in such situations, there is nothing additional. Both the masses are moving in the same direction, right? So
Oh,
we could easily
yeah.
combine them. But let's go through the solution which we did last time. So first thing we learned is what is Newton's second law. In Newton's second law, we said that the sum of the net force is equals to ma. This is the Newton's second law, correct?
Mhm.
And from here, we actually define how do we find the acceleration of a system. So we're talking about a system, right? We have two bodies. It's a
Yeah.
system, right? So in the system, we'll work out a net force and then equate that force to ma, right? Mass into acceleration. And mass
Right.
of what? Mass of where it is really acting and acceleration on that particular mass. Correct? We also did some assumptions, and in most of the cases, we have a light string, inextensible string, and a smooth pulley, if at all, and we are assuming there is no friction anywhere, correct? So
Right.
those are the things. Now, when we say light string or an inextensible string, what does it really mean? Can you, Amy, please read this part?
Yeah. So mass of the object is negligible compared to other masses. The force exerted at one end is transmitted undiminished to each adjacent piece of cord along the entire length to the other end. So
Correct.
meaning the tension is the same at both ends of the light
Perfect.
string.
Perfect. This is very important. And that helps you to understand the role of tension
Mhm.
in such a system. Yeah, inextensible string.
So this is a string that does not stretch,
Mhm.
meaning the acceleration is the same in objects at both ends of the light string.
So in both the objects, same acceleration. You get these two are
Right.
very critical points to understand, and therefore these words are purposely put into your question. right?
Oh,
So the
okay.
tension is same in the whole system, and the acceleration of both the objects is same, is it? In when we take two objects, correct? So that is what it is. Now, when we solve such a question, we can actually work on the general masses m1 and m2. And during the solution, as you understand, we need to draw a free body diagram, describe the assumptions, relate the parameters, and solve the equation. These are very important for any solution. They may be asked for or may not be asked for, but it's very important for you to list the assumptions while you are solving the questions. Also,
Right.
make a free body diagram. So let's make a free body diagram of these two masses. So we just made the free body diagram, mass 1, mass 2. Mass 1 is the first one, which is being pulled by an external force, and there is a tension, which is because of the string, which acts in the opposite direction. Force of gravity is nullified with the normal force, which is acted upon by the mass. So we have the first free body diagram. And then for mass 2, there's only a forward force, which is because of the tension in the string. And this tension is same in both the cases, since it is an inextensible string, light string, correct? And the acceleration of both the masses is also same. You should explain this from the assumptions which we just did. Do you understand?
Oh, right.
These two
Yeah.
parts are actually very critical. When you take this assumption, write them on the right hand side, explaining why it is so.
Okay.
Right?
Yeah.
We are actually heading for 100%, right? We don't want to leave anything, right? So
Right.
body
Yeah.
diagram is absolutely clear to you. Once these diagrams are there, we can write a very simple equation. Fp equals to ft, right? Very clearly. So we get the equations from there. Since the first box we see forward force is Fp, backward force is Ft. It is moving forward. That means the forward force is greater. There is a
Right.
difference of forces. Difference of force is the net force. So on the left side, we have the net force, which is the force which is being pulling the object, and Ft, the tension, which is acting backwards. And this
Mhm.
net force should be equal to the acceleration of the first object, correct? M
Yeah.
equals A, right? From the second one, we only have one force acting on it, the force of tension, T or Ft, which I have been using in my nomenclature, acting on this mass of 2, but it is also moving with the same acceleration. Therefore, this net force should be equal to ma, mass being m2 in this particular case, right? General.
Mhm.
So here we have a very general solution. As you can see here, tension acting here. In one case, the tension which is acting in this direction, the other case in that direction, logically, they should cancel away when
That's
you
how.
add this, correct?
Yeah.
So what
Yeah.
we normally do is we have two equations, equation 1 and equation 2. Just add them up. As soon as you add them up, you see this ft and minus ft, they cancel out.
Cancel.
And so when you add them up, here we see that what happens. When you add them up, ft minus ft cancel away, we are left with tension. Uh, when taken away, only acceleration is the unknown. So fp is a times m1 plus m2. Simple algebra, just divide by a sum of masses and you get your answer. So the
Mm.
next formula becomes A equals to the forward pulling force, right? Which is actually the net force in this case, the only external force. There is nothing which is there
Yeah.
downwards. So that net force should be equal to, we are treating that as one system, m1 plus m2. Then net force is acting out
Mm.
on the mass of m1 plus m2, right? So that is equals to mass of m1 plus m2 times A. So A is the quotient of net force divided by the total mass. So simple. Do you see that?
Yeah. Yeah.
And so we can put whatever values are given in the question, find the answer. Once we get the net force, once we get the acceleration, in that case, always use the last body. You see that? To find tension. To find tension, always use the last body. Do you see
Because
that?
it's straight. You can get the answer directly.
Not
Yeah.
this, okay? We want the box 2. So
Right.
box 2 says Ft is equals to m2a. We know
Hmm.
the mass of that body. We know the acceleration now. Calculate the tension. You get the idea?
Saves
So
time. Yeah.
this tension is now the external force on the last body, correct? And
Yeah.
this is the only force on the last body, which is accelerating with a. So net force is equals to ma. You find tension, which is
All right.
net force on the last body. And we
Yeah.
have learned that we could have number of objects in between, right? We could have many objects in between. The
Always
problem
pick the last
solved
one.
in the same way. Add all the sums and divide it by the force, and you get the acceleration. Once you get the acceleration, only look into the last box.
Right. Yeah. Doesn't
Find
matter how many boxes are in
tension of
between.
the string from the last box. Very simple solution, which we did. And then, this was two on one table, no tension. No friction. Okay. But
Mm.
we introduced you with second level of question, where one body was hanging with pulley in between. So now we have introduced the force of gravity in this particular case, right?
Yeah.
One
Yeah.
body is still on the table, the other one is hanging. Now, in this case, how do we solve the question? Can you please read this question, Amina?
Yeah. So two boxes with mass of M1 and M2 are attached at the end of a light inextensible string. The string passes over a fixed light pulley as shown in the figure.
Yes,
Find general expressions for acceleration of each box and tension in the cord.
correct. So this time we made our system with two masses. So we'll be interested in now finding a general expression. Once you have the general expression, well, you can solve all the questions in your book by placing the values, whatever they have given in the book. Find the unknown, correct? The
Yeah.
idea here, once again, is that when you have these two bodies, then this is a diagram which is showing you the situation, correct? So the two masses, M1 and M2, M2 being there on the table, and there is no force of friction between the mass and the table, assumed. Frictionless pulley with light inextensible string. All these things will give you the assumptions which you have taken. List those assumptions. It will take a minute for you, but that will be very important from communication point of view. Is that clear?
Okay. Yeah.
Once you have that, then you have to now make the free body diagrams of each, correct? And then
Yeah.
write down the equations, correct? So that is how we are going to solve this particular question. Is that clear to you? Right?
Yeah.
So let's go with the two masses. We know what is the net force. Let's see. Okay. So I just want to see. Okay. Anyway, uh, we'll get back to this, right? So what do we see here is that if you look into the mass M1 in this particular case, M1G is the force acting on it, and there is a tension Ft which is acting upwards, right? Acceleration is acting downwards since this mass M1 is pulling it.
Going down.
And
Yeah.
what is the external force? This external force is due to gravity. Do you see that? So in this case, the gravity is the external force, and therefore it is pulling it up. But the tension is pulling it upwards. So we get one equation with the mass M1, which is the net force is M1G, which is pulling it downwards, and the tension, which is pulling it upwards. And this
Right.
should be equal to M1A, right? And so we get one of the equations. The second equation we get from the second mass, which is being pulled because of the tension in the string. This tension is exactly similar or same, which was there here, right? Same value. So therefore, Ft equals to F2A becomes a second equation, correct? Idea is exactly same. What are we going to do? We're just going to add them up. Then this cancels. Find acceleration. Once you find acceleration, substitute the value from the second equation, find the tension. Do you see that?
Yeah.
Exactly similar to
Similar.
it earlier. Now,
Yeah.
last example we did was for the pulley, correct? Can you read this question now?
Yeah, so the two boxes with mass of M1 and M2 are attached at the end of a light inextensible string. The string passes over a fixed light pulley as shown in the diagram.
Yes.
Sorry, figure. Same thing. Find general expressions for acceleration of each box, tension in the cord, and find the acceleration and tension if M1 is 6 kg and M2 is 4 kg.
Correct. So the idea is exactly the same. You have to find only these two things, acceleration and tension. If you are given some value, substitute and find the answer. Simple as that, correct? Now, this system is slightly different from the other systems. In the other systems, you could have combined the masses. They were moving in the same direction, correct? Now, these guys are moving in the opposite direction. Mass M1 is going down, M2 is going up. Do you see that part?
So you can't
have
treat
to
it as
split
one
them
system.
into two different systems.
Oh, yeah.
Okay. Now, first thing is we have to draw a free body diagram for this system, and then we have to write down our equations, correct? So what I've done here is I've made the free body diagram. Because separately. Like these are the two, right? Free body diagrams are shown there itself. Mass
Mhm.
M1 being pulled by M1G, and Ft is the tension, which is acting it upwards. And that gives me the very first equation, M1G minus Ft is equals to M1A. You see, these
Yeah.
equations are same in all the three examples we discussed so far. They actually
Yeah.
remain same. This second mass, which is going upwards in this particular case, because the tension is pulling it upwards, but there is a force which is acting it downwards, gravitational force, correct? Therefore,
Yeah.
the equation now becomes the tension minus the gravitational pull, that force, is equals to the acceleration of the body, m2a.
Hmm.
Is
Yeah.
it clear to you?
That's clear.
Now again, we get two equations. Do you see that?
Hmm.
So once you get this, then you can add them up. And as soon as you add them up, you get a general formula. So we have a general formula after adding and isolating A, correct? And you get your general formula. Once you get the value of A, plug it in and find tension in the string. So you do get the tension also a general formula, which has been derived earlier as you have seen this, correct? Once
Hmm.
you have the general formula, given the values of the masses, you can plug the values, calculate, take care of significant figures in the units, which is again a very important part. The whole idea of doing this exercise was to make you understand that when you plug in the values given to you, you have to calculate your answer to the required significant figures. Is that clear to you?
Right. Yeah.
So
Yeah.
once you've done that, then you have done it correctly. Now, from here, we move to your example. And in your example, we don't have a pulley, but we have two masses attached with a string, correct?
Right.
So now what I will do here is that, uh, let me just, okay. So in the summary, what we saw here is that we saw three different cases, two bodies on the same table, one body with a pulley and another body hanging, and then with a pulley, two bodies on the side. And we summarized with formulas, which we derived in these particular examples, correct?
Yeah.
And if you just see these formulas, you will know how to solve these kinds of questions. Is that clear to you?
Hmm. Yeah.
Correct. Now, what I will do here is I'll add one more page to it and I'll try to solve your question. Is that clear to you? So,
Okay.
why don't you read your question and let me make a diagram to understand and then solve it. Correct. So, can you please read your question?
Yeah. So two particles, A and B, of masses 10 kg and 5 kg,
Okay. So,
respectively,
wait. So, we have two masses. Yeah, you can read the whole sentence. Yeah.
oh, are connected by a light inextensible string.
Correct. So, we have
Part,
two masses,
yeah.
A and B. Yeah, writing vertical on the screen is slightly difficult. They are connected by light inextensible string. Yeah, then what?
Um, wait, so we need to write what light and extensible mean, or should we do that
No.
later?
So those are the assumptions which we discussed. You have to
Yeah.
put that, right? So
Okay. Do I physically write that in the exam on the side?
yeah, I'll tell you how. So read the
Okay.
further and we'll see how to solve it, right?
Okay. So particle B hangs directly below particle A,
Mhm.
like you did, and then a force of 180 newtons is applied vertically upwards, causing the particles to accelerate.
Okay.
Find the magnitude of the acceleration.
Oh, I see. Okay. And are the masses of A and B given to you?
Yeah. So A being 10 kg and B being 5.
Okay. So these parameters are given to you, right? So what we will do here is we'll try to solve this particular question in a very general way. So we'll say the two masses are MA and MB. The force is F, right? That is what
Yeah.
it is. And now we'll make first step is to make a free body diagram. Is that clear to you? Let's
Okay.
start with A. So in the case of A, that is the body A on the top. We have a force F acting on it, correct? Now, what is pulling it down? One is the tension,
10 G.
and the second is the mass into acceleration, right? The
Yeah.
gravitational force acting on E, right? So, which is ma. Is that clear to you? So
Mhm.
that becomes the free body diagram for A. And that gives you the first equation, and that is external force F minus T minus ma
MA.
into g is equal to what? This is the net force acting on this body, correct?
Yeah.
And the body is moving with acceleration a, correct? So that means this is equals to ma a from Newton's second law. Is that
Yeah.
clear? So
Yeah.
we'll say, well, this is from the Newton's second law. This is what we get. Now, let's look into the second body. So this is equation 1. In the second body, let me draw this also, right? So we have this mass B. Now this mass, the tension is actually pulling it, right? So this is the tension which is pulling it. However, the weight of the body is the force acting downwards, which is mbg, correct?
Yeah.
Is it clear to you? So
Yeah.
in
Yeah.
this particular case, we get the second equation, which is T minus mbg, correct? And that is equal to the acceleration into mass, right? So mb
A.
into a. We get the second equation. Do you see how easily we got two equations?
Yeah.
Now what we have done here, we have taken these two tensions same. That means the string is inextensible light string. You see that? So why this tension is same? In extensible light string, and we have also taken this acceleration as same, correct? So once again, let me just show you here. So when we say light object, that means mass has been neglected, correct? And the tension is the same in both the strings. That is because of the light object. Inextensible, it is not like elastic, it is not rubber.
Yeah.
Right? It is inextensible, and therefore the acceleration is same in the string for both the bodies.
Yeah.
So
That's clear.
that is how we are going to use our assumptions when we are defining why T is same, right?
Yeah. Yeah.
Why mf minus m1? The string does not have any mass. We don't have to consider the mass of the string, correct? That is the light body. Is it clear to you? So that is how you should explain or write those assumptions in between if they are not asked for separately, right? Now, okay. So first step first, what do we do normally? Well, we know we are just going to add this up. As soon as you add them, you know this T and T cancels, correct?
Yeah, it cancels.
And you get F minus M1A times G minus MB G equals to MAA plus MBA. Is that clear to you? Well, now you need to isolate A, right? So we could write this as F minus sum of the masses, MA plus MB, right? Times the gravitational force. And here, the sum of the masses, MA plus MB times A. And therefore, what is A equals to? Well, for getting the value of A, we can write down the general formula. And that is A is equals to F minus MA plus MB times G. Is that okay?
Yeah, over sum of masses.
Sum of masses. You see?
Oh.
Sum of masses. Do you see? So this is
yeah.
directly from Newton's law. This is a net force, correct?
All right. Yeah. The mass. Oh.
So basically, in this example, we considered this as one system. Do you see that? And we were pulling this system up. You get an idea?
Yeah. So even though you like individually did a free body diagram for A and B, you still considered the whole thing as one system because they are moving in the same direction.
Shortcut method, right? Force minus total gravitational force, correct? Total gravitational force is because it's sum of both the masses, correct?
Yeah.
And the acceleration is on the both the masses together, MA into MB. Get the idea?
So unless the objects in the system are moving in the same direction, then you consider it as a whole system. If they're moving in opposite directions, like the pulley, you can't. Okay.
You get the
Yeah. It's clear.
Once the concept is clear, how easy it is. Now, you are given F as 180, substitute 180 here. 10 and 5, just substitute A is up.
Right.
10 and 5, 10 and 5, get your answer.
And we know G is 9.8. Yeah.
Once
Cool.
you find A, what did I tell you? Go to the last word. In this case, equation 2, right?
Yeah. Yeah.
Substitute the value of A. You know what gravitational pull is, 9.8, right? And then
Yeah.
all other things are known to you. Find tension.
Oh, yeah. So it doesn't matter whether the system is like vertical upward or this way, always do the last box in terms of when trying to find
Correct.
tension, since that's the
Because
only
you're
force
pulling
acting
it
on it.
upward. You're pulling it upwards. The last box is B. You see,
Yeah.
you're pulling it
Yeah.
upward. So the last one is at the end, which is B.
Right. Right.
And if you write the equations in order, as we did in most of our examples, so equation 2 will give you the tension.
Oh, okay. Yeah.
T for 2, right? T for
Mhm.
tension. So equation 2 will give you tension. You don't have to worry about it.
Yeah.
No tension.
Yeah. That's a nice way of thinking of it. Two, like the second equation, two, tension. TT.
So it
Okay.
is very important to follow a model, right?
Yeah.
And
Yeah.
a process. If you think like logically in that sense, then everything comes in place. And as you read the question,
Wow.
the solution is there on the paper. You get the idea?
Right. Right. Yeah.
So that is how you have to solve the questions of your book. Now, can you once again read the question? So I think we solved the first one, not a problem, correct?
No. Yeah. It's
With these
clear.
values. Can you read the next question and let us see if we can solve that one now? Yes, please. Can you
Okay.
read it?
All right. So it's kind of similar, but yeah, values have changed.
Mhm.
So two particles, A and B, of masses 6 kg and m kg, respectively, are connected by a light inextensible string.
Mhm.
Particle B hangs directly below particle A.
Mhm.
A force of 118 newtons is applied vertically upwards,
Mhm.
causing the particles to accelerate at 2 meters per second squared.
Okay.
Part A.
Hmm.
Find the mass m of particle B.
Mhm.
And part B, find the tension in the string.
Tension the string. So we have to always find acceleration, tension, or in this case, masses, correct?
Mass, yeah.
These are the variables. Now, very simple. In this particular case, what you note is you don't know one of the masses, which you need to find, correct? But you know the acceleration. So
Instead,
even if
yeah.
you use this particular formula, let me use a different highlighter this time. So we know this, right? We know what A is, which is 2 for us. We know what F is, which is 118. We know one of the masses, and we know one of the masses. The only thing which is not known, gravitational force is constant, is the second mass, right? This is what we don't know. Substitute these values,
You
isolate,
got
and
it. Yeah. Nice.
right? Or, I mean,
Yeah.
whatever you do, right? So the idea is when you add these two equations, the tension cancels away.
Cancels.
You are left with one equation which has only acceleration with all other parameters without the tension. Correct?
Right. Yeah.
Substitute in that equation, find the
You
missing
got it.
parameter. Find the
Oh.
missing parameter. Once you
Mhm.
find the missing parameter, then go for tension
Right.
with full force.
Yeah. 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 That's nice.
Find
Okay.
the tension.
So I think, yeah. Well, so like you said, make it like a general equation for yourself and then just sub in the values.
Yes.
Oh.
Is that clear to you?
Yeah. Yeah. Definitely. That
Perfect.
really
So,
like consolidated everything. Thank
right.
you, sir.
So I think you've understood the process. I mean, can you
Yeah.
please explain for the benefit of our students, like how should we go about in solving these questions of mechanics?
All right. So, well, there, like you said, sir, so many of these questions they are very similar. And in terms of if you learn like kind of each of the different things, like the one with the pulley, the one on the table, the one that falls off, and then one on top of each other, because
Yes.
those are the ones that just keep coming up. If you just know roughly what's going on, then basically you can answer any of the questions in the whole mechanics section for year one. So yeah. But in terms of like knowing the assumptions is very important because if you don't know that, then it makes the question really hard, because if you think like really practically and logically, it won't make sense. So if you think about being light, we talked about the tension being constant throughout because it's a light object, and being inextensible means the acceleration is constant throughout. So knowing these two factors is very important. And what we did in terms of answering the questions, we were talking about when treating the system as a whole and when you treat it individually. That's in terms of objects within that system, are they moving in the same direction? If so, then treat it as a whole. And if they're not, like a pulley, you treat it as individual things. I found when you drew the free body diagrams for some individual aspects, that made it a bit clearer for me to know like what forces are acting on what objects. And finally, in terms of when trying to find the tension, the small little thing we talked about, when after you find your equations, always the second equation, so being 2, you find the tension, since usually the last object is the tension's the only force acting on it. So it's so much easier if you just sub in the values and find tension directly than trying to do it the long way. So yeah.
Beautifully summarized, Emmy. I think you got all the concepts and not write all the questions in your book. If you have any
Yeah.
difficulties, get back to me. And from here, so what is your next topic?
In terms of mechanics, or?
Yeah, in terms of your revision, right?
Oh, my revision.
Yeah.
Well, I was kind of doing vectors. I spent all of yesterday doing vectors. So
Vectors, that's very
yeah.
So mechanics will be useful there in vectors also. So in our
Yeah.
next class, we'll talk about how do we solve questions based on vectors and how do we prepare for it in our while
Review.
getting review for the exam.
Yeah.
We'll end this session here. Thank you, Amy, for all this.
Thank you so much, sir, for your
See you in
help.
the
It
next
really
session.
helped. Thank you.
My pleasure. Thank you. Have a
Bye,
great
sir.
day. Bye.